Hi everyone, so in this demonstration we're going to be looking at rationalizing denominators, and rationalizing means taking them from an irrational form such as this, the base, into a rational form, and sometimes it's important to do that, and in the process you may actually end up making irrational numerators, but it's more important to have the denominators as irrational. So this is something to practice now and get into. So the trick to these ones is to take the fraction with the irrational denominator that you want to make rational, and to multiply the top and bottom effectively by 1. And I'm just going to change my pen color here. And 1 is makes the fraction, any fraction, into a disguised fraction or a similar fraction. Now that is 1 there. I've multiplied that by the same number over the same number, which is the base over the base, and that's timesing it by 1. And so then when I work that one out, it's square root 2 times square root 5. So we're just going to put square root 10 up there, and on the base, if we have a square root of 5, let's just do that down here by square root 5, that is the same as square root 5 all squared. And so you have a square root key and a square key, so we've done nothing to 5. All right, so what that does, it just makes the number, it takes it out of the surd because we're squaring it, we're timesing it by itself, and it was squared as well. Okay, so that's the answer there to that one. Square root 10 over 5. So as you notice, we have actually effectively made an irrational numerator, but we have done the job of making the denominator rational, so we've done the trick. I know it's a bit odd, but that's the purpose of all this. With this guy here, we just need to multiply this particular fraction just by the surd part, so we're going to multiply it by square root 3 over square root 3, which is just timesing it by 1, which is renaming the original fraction. So we're going to have 6 times square root 3 on top there, and then 5 times just plain old 3. So 6 square root 3 over 15. We just need to look here to see if we can maybe simplify this fraction. We've done all the work, and that is an answer, but not the simplest form. So if we look at the digits 6 and 15, we'll see if we can divide those by a common factor, so we can simplify 6/15. So the highest common factor going into both of those is 3. So we're going to need to divide top and bottom by 3 over 3. So what that does, it's going to leave us 2 square root 3, and 15 divided by 3 is 5. For this next batch of demonstrations here on example 20, we are multiplying by the conjugate surd expression. Okay, so conjugate is just a complementary surd, so that's another term for it, is complementary. And all it is something like x plus y. Its conjugate is x take y. Something like A take B, its conjugate is A plus B. So we're just changing the sign in between. And it's just a simple strategy that helps us with some slightly longer ones. So when we look at A as our first example, the entire term needs to be multiplied. So I'll just write A down first. Square root 7 take square root 3. We're going to multiply that by square root 7 plus square root 3. Okay, so we've done the first part. Now they want us to multiply it. So let's multiply that out. We're going to use FOIL. So we're going to do firsts, outers, inners, lasts. 1, 2, 3, 4. We're just going to work carefully through that. And so square root 7 times square root 7 is square root 7 squared. And then we're going to go for the second one, square root 7 by square root 3. Just going to put them next door to each other. And the third one is minus square root 3 times square root 7. And the last one is a minus sign, square root 3 all squared times by itself. So what we see here, sorry, I forgot the sign in the middle there, the plus. So I'm just making sure I have that wee intermediary sign there between the expanded terms. So I have 4 terms. If I eyeball that carefully, what do we see? Well, the first, well, maybe one of the things you see is have a look at these 2 terms here. We have a plus version of the same thing where we have a minus version. So we have plus square root 7 square root 3 and minus. So that just cancels out. So this is why we do these things, because they lead to simpler strategies where that just becomes 0, plus and minus the same term is 0. And then the other thing we can look for to eyeball is the first term itself, square root 7 squared. We know if we square root and square a term at the same time, we are doing and undoing an operation. So we're just left with 7. And at the back, same thing with the 3, we're just left with 3. So there we go. Oh, look at that. Even reduces down to 4. Now, as I'm working through that, just have equal sign down the page. So I'm just working mathematically down, down, down the page. It's showing that that 4 is actually what that is. That is equal to 4. So after all that, we have a really nice final answer. Cool. Okay, let's look at the next example, B, which has a little more complexity to it, but not a lot. So first term. Okay, so we're going to multiply the term that we're dealing with by its conjugate. So it's 2 square root 3 minus 1. We're going to expand it out. I'm going to FOIL it out. Let's just put the that by that, that by that 1, 2, and then that 1 by the first term there, and 1 by that one there. So that's step 4. So let's do this thing. So 2 square root 3 is multiplied by 2 square root 3. That's the first part. And we're also taking away one lot of 2 square root 3. Okay, so that would be times 1. So I'll just leave that at that. Plus part 3, one lot of 2 square root 3. And at this stage here, if you look at the guts, the middle two terms here, they're going to disappear away, aren't they? Because we have minus and plus the same term. So later on, that's going to be really good. And the final term is positive 1 times negative 1, which is just negative 1. So let's do the bit that we highlighted as interesting, which is the minus plus the same term. Those two just disappear out. And now let's tidy up the first term, which we have 2 times 2 is 4. Square root 3 times square root 3, square root 3 all squared is just 3. So 4 times 3 is the first part, and we're minusing away. The sign doesn't count anymore, so it's this. We're minusing away 1. So it's 12 take 1, which is equal to 11. Okay, so we've now done part B, where we've reduced it down to a single value. At this stage, it's important just to highlight that the 12 minus 1 was the first term squared by that term. This is why we do the conjugates. Okay, so the 12 came from, if we just rename this top thing as A minus B, A plus B, or A plus B, A minus B in this case. When we multiply the two first terms, A squared, that's the 12. So this reduces, in fact, to A squared minus, because we have two different signs up here between the brackets. So we have a plus and a minus. So the in-between sign is minus. The middle two terms, terms 2 and 3, fall out. The guts falls out. And so what we're left with in the reduction is the last two terms, the B terms, squared together, because they're the same number. Okay, so the B terms squared together is minus B squared. And so A squared in this case was 2 square root 3, and the B term was 1, 2 square root 3, so it's A squared minus B squared. So that was our 4 times 3 minus 1. So what does that mean? That means that you can safely jump to this without doing a full expansion. So you don't have to FOIL it or not. You can just jump straight down to that, which is how the example treated that one in the book and the ones to come. So let's go on to those ones now. Okay, so these are the types of problems you'll need to do. So we're going to take this value here and we're going to multiply it by its complementary term, or the denominator. So that part there, we're going to times top and bottom denominator. So what we're going to do to this equation is times that by square root 7 take square root 3 divided by the same thing. square root 7. Sometimes you talk and you put the wrong value down, and that's how I know students make mistakes as well. So let's just make sure that that says 7. Okay, and so then we're going to divide it by the same value so that we're not changing the fraction, we're just renaming it. Square root 7, it should be plus, top and bottom, square root 3. Okay, so I've done enough there to start that one off, start the process off, even though it's riddled with mistakes, or I have been. Square root 7 plus square root 3. So now what I'm doing is I'm multiplying across the top, the numerator parts and the denominator, just to bring that fraction together. The base is square root 7 takes square root 3 multiplied by square root 7 plus square root 3. Next step here now is to sort this fraction out. So straight away I'm going to apply the, this one here is the same as a squared take b squared. So I'm going to shortcut that process right down. So the a part of it is the 7 square root, and when we square that, that just becomes 7. And we're subtracting the b squared part of it, which is square root 3. And if we square root that, it's just 3. So the denominator is going to be 4. And the numerator, we just need to have a little looky at this and see how we're going to treat this, because it's not necessarily the same. Okay, so when we look at this here, we have a bracket term, an expanded bracket, so it might pay to expand that out. But before doing any of that, what I'm actually going to do is just write the workings fully in. And I had a little nosy at my textbook, and let's write all the steps to date so far, and this is important tidy working in mathematics, over 4. Now by doing this, it allows me to see that there is a common fraction here that can be simplified before expanding out. So I don't need to deal with the expansion, I don't need to deal with that 2 if I just cancel out top and bottom. So 2 over 4 is equivalent to a half, so the 2 stays on the bottom. So this entire fraction therefore reduces to square root 7 plus square root 3 all over 2, half or half of. And so effectively we have done what we've been asked to do, and that's the best we can do. So we've rationalized the denominator. Yes, we have. We've made it a rational number instead of the square root business. And not only that, but a slightly complicated one. And in doing so, we have made the numerator irrational, but that is our preference in mathematics, because that's fractions that have rational denominators are easier to work with. Okay, let's do the second one. The second one is square root 6 over all that. So I'm just going to run the workings up here. I'm going to be multiplying that fraction by its conjugate, which is the entire 2 square root 3 take 1 on the top, and the same thing on the bottom, 2 square root 3 take 1. And effectively it is the entire same denominator, but I have changed the pluses to minuses, which will allow us to apply that rule of a squared minus b squared, because we have an a and a b term and an a and a b term, and because the signs are different in the middle, I can just cut to the difference of squares rule. Okay, difference of squares. Difference means the plus minus aspect, and squares there, so that's the rule there. So let's work this one through. This time I'm going to start with the top, square root 6, so that all equals square root 6 multiplied by 2 square root 3 take 1, and I'm going to put a bracket around that because square root 6 is multiplied by each of those, and that's 2 terms, and so when we multiply it by a third number, each term is multiplied by that. And at the base there, it's the a squared minus b squared term, so I'm just going to look at the a part of it, which is 2 square root 3. We're just going to square that. We're just removing the guts, we're just cutting straight to this equation here, and we're not going to multiply it all out using 4, so it'll be plus 1 multiplied by minus 1, which is just take 1. I'm now going to form tidy up processes. So what I'm going to do is I'm going to tidy up the top. So I'll just leave it for now as it is, and that was multiplied by 2 square root 3 take 1. By writing it out, it just looks a little bit better. That's square root 6, not 16. Hardly looks better at all, does it? Okay. And then the base, let's tidy that up. So we can see here we have a square root term there and a square term here. So we're really doing nothing, so we're just going to take that one out. However, the squared term here applies to our 2. So before we do anything drastic, we're going to square out the 2, which becomes 4, and then we're going to square out the square root 3, which just becomes 3. So it's largely like some of the earlier problems we had. And so that one there, we'll just multiply that out. 4 3s are 12, take 1, which is 11. So I'm going to just write 11 down there and skip all that intermediary working because you can see that. Now what we're going to do with the top part, we're just going to put that tidied up and put it here on the top part in our next line of working. I'm going to expand that bracket out. So I've got square root 6 by this term and square root 6 by negative 1. So it's just going to be a single bracket expansion. So square root 6 is multiplied by 2 by square root 3, and it's also multiplied by 1, so it's take square root 6 also. Let's close that up a little bit. Top line is 2 square root 18, take square root 6, and bottom line is still 11. So looking in and how we can tidy that a little bit further, this square root 18, 18 is a factor of 9 and 2, as well as 6 and 3. 9 and 2 is actually better for us today because the 9 we recognize is a perfect square, so the square root 9 is 3. So we want to consider this combination of factors on this one. So in fact, square root 18 can be rewritten as square root 9 by 2, and that in turn can be written as 3 by square root 2, which is 3 by square root 2 like that. So that has simplified. Square root 18 simplifies down to 3 square root 2. We're just making the surd part the smaller, so we're simplifying that surd as in previous work there. I hope you've done. So let's tidy that whole thing up now to 3 square root 2, take square root 6, divide by 11. Now I'm looking around there to see if there's anything else that I can do with that guy. My worked example has that as the base finish, so I think we'll go with that. Let's just satisfy ourselves that that is the best we can do. This one here is down to the simplest irrational term. I can't pull anything out of that, and I can't factorize that out. Well, I kind of can, but I have it in an expanded term. If I kind of can, maybe I'll have a little play with that shortly, and that 11 is a prime. If I take that term on the top line, the numerator, 3 square root 2 minus square root 6, one thing I could do, just have a wee little play with that, and recognize square root 6 is made up of square root 2 by square root 3, which allows me to square root 2. Maybe factorize that. So I can see that square root 2 is common to both of those two terms. So I have two terms here separated by a minus sign. So realizing that's common, I could take that out in a bracket and leave 3 and square root 3 in a bracket. So let's factorize that. So that is equal to square root 2 coming out, 3 staying in the bracket, and minus square root 3 in a bracket. And that's okay. So what I could do is put that term there, all over the 11, and so that's an alternative way to present the answer. In terms of have I done the job required me to rationalize the denominators in each of those. And each of the following. So I've done that in both cases. So whether I look at this form, which the book left it at, or this form, which I think's a little tidier because we've got the numbers down just a wee bit smaller and we've dealt to that square root 6. Maybe it is, maybe it isn't. I think that they're kind of equivalent. So if you went that one step further and did this, you're not actually complicating that any much more than it is, just factorizing the top line. Up to you.